Okay, hello students, now we will see the volume of a certain solid region. So how are you going to find the volume of a certain region by using the integration to mean? Here we have a definition of volume. It says let S be a solid that lies between x equal to A and x equal to B. That you can see it here. This is A and this one is B. So this part is all the solid region is represented by S. If the cross-sectional area of S in the plane is P of X, just you can see it here, we have the cross-sectional area where if we cut by the plane, okay, by a certain plane, we will have a certain cross-sectional area, okay? So this could be the cross-sectional area, A of X. So, or we can say it's P of X, don't worry, just to align with this. So just we are cutting the solid region on the point X, okay, on the point X by a certain plane to mean, and which is perpendicular to the x-axis. Yeah, so the plane is acting perpendicular to this x-axis. Great. So this is A of X, because if we cut it, this solid region, definitely there will be an intersection between the solid region and the plane. If we say this one is the plane, for example, like this, okay, cut. So the intersection is simply AX, where A is continuous function. Yeah, because like if this one is AX, we can have a certain continuous function like this. So the volume of S is simply given as V, which is the integration from A to B, area of the cross-section that we consider, times dx to me. So before coming to this integration, finding the volume of this solid region S is simply what? It is the summation of the areas at xi, where this one is xi, you can see it, times change in x. So change in x is the thickness of the area, okay? The thickness of the area. So we have the thickness of the area, that is change in x, and we have the area by itself, which means when area times height, it will give us what? Volume, yeah? For example, if we have just like a certain cylinder, how to find the area? I mean the volume. The volume is simply the base area, then that is pi r squared times what? Times the height, yeah? This is height. So in this case, the height is change in x to mean, okay? And this one is A of X, area of X to mean. But this one is for one cross-section. So if we have infinitely many slices, okay, slices on this, which means we can sum up the volume, yeah? This is area times height, or the depth, okay, or the thickness. So this one is VIs, okay? How many VIs do we have? Just many. So look at here, for example, we are trying to approximate this S by this one, which means this one be V1, this will be V2, this will be V3, V4, V5, V6, and V7, you see? So how to find the volume of this V7 or V1? Just we have this area, AX, yeah? And the thickness is from this to this, change in X. So these are change in X, okay? And different areas we have. Yeah, so upon adding, which means if we add them, 7 of these, that is VIs, I from 1 up to 7, just we are approximating the volume, not exactly, yeah, because we have some errors, you can see it here. But now, if we sum up to infinite, that is summation, infinite summation, where n is approaching to infinity, just this will be directly changed into what? Into integration. So the integration from A to B times the cross-sectional area, and with its variable of integration, d of x will be the volume to me. So simply volume is defined as the integration from A to B times the cross-sectional area times dx to me. So this will give you what? The volume of the solid region S to me. Okay, let's see some example. So here it says find the volume of the solid obtained by rotating about the x-axis. The region under the curve y is equal to root x from 0 to 1. Great. So in order to find the volume, what you have to do is, we are going to rotate, yeah? It says, find the volume of the solid obtained by rotating, you see, about the x-axis. Which one? The region under the curve y is equal to root x. So this one is our root x, as you can see it. Okay, this one is a graph of root x. And from 0, this is 0, and this one is 1. Now, upon rotating this region, you see, upon rotating this region, just imagine along the x-axis, it will come up like this, you see? Yeah. So when we're rotating, just like imagine what type of curve it will create. Okay. See, upon rotating, see, just like we'll obtain like this shape, yeah, like this shape. So this will be like a solid region, as you can see it here, like this. So upon rotating this y is equal to root x, you see, it will come here and rotate along x-axis, and you will produce the solid region S. So this is what the solid region is. Okay, so how are you going to find the volume of this solid region? So as I told you, you have to make it, volume is simply the integration from A to B, the cross-sectional area times its thickness. Okay, now if you cut this solid region somewhere here, you see, you'll obtain what? You'll obtain circle. If you cut here, you'll obtain circle. If you cut here, you'll obtain circle. That is the intersection between any plane, cutting plane, and this region will be what? Simply a circle. You will obtain this circle. And you know how to find the area of a circle. That is pi times radius squared. But what is your radius? You see, the radius is simply what? This function root x. This is y is equal to root x. So the radius is root x, whatever it is. Okay, dx is the variable of integration, yeah? Great. Now the volume V is simply the integration from A to B, A of x dx. But the intersection between the solid region and any plane is simply what? Simply what? It is a circle, yeah? So the circle is from 0 to 1, and the area of a circle is pi r squared dx. But our radius is what? Y, that is root x. So upon substituting, we will obtain 0, 1 pi times root x squared dx. And this is simply the integration from 0 to 1 pi x dx. And integration of this is pi times x squared over 2. And upon evaluating from 0 and 1, you will obtain pi over 2. Okay, unit cubed. This is the volume to me, you see. So the volume of this region is simply pi over 2 unit cubed. So it is possible to find the volume by rotating a certain function along x-axis or along y-axis based on the given question. So upon rotating along x-axis, this will obtain this figure. So this is rotation, yeah? Rotation along x-axis domain. Okay, another good example here we have the region R enclosed by the curves y is equal to x and y is equal to x squared is rotated, you see, about the x-axis. So when you rotate, we will produce another solid region to me. And the functions are simple. Y is equal to x is this, and y is equal to x squared is the parabola this, y is equal to x squared. So as you can see, we have what? We have a certain intersection or bounded region graph. So upon rotating this bounded graph along x-axis, just you'll obtain what? This will come here, and of course, it will be of this type. Yes, so upon rotating, just will make a certain shape like this. Okay, this is a region given for us, and upon rotating, you'll obtain this region. So this is our region, solid region. Okay, yes. And what do you expect if we cut here by a certain plane? Okay, which means what will be the intersection of any plane with this solid region? Definitely you will obtain the annular region. Yeah, this is annular region. That is the region obtaining by cutting this solid region by a plane. Yeah, a plane. So this is annular region to mean. So the idea is to find what? The volume of this solid region. The volume of this solid region. So the volume will be what? Volume is simply, as I told you, it is simply the integration from AB f of x dx. But what is A and B? We have to find them because it is not given directly. And what is f of? No, this one is A of x, area of x. And the area of the annular region is what? If you go here, what is the area of this region? Annular region. Area is simply what? Area is simply pi r squared or pi r1 squared minus pi r2 squared. So r1 is simply x and r2 is x squared to me, because you can see that the smaller radius is x squared and the bigger one is y is equal to x. You see? So this one is x and this one is x squared. So in this case, we'll have what? Pi x squared minus pi x squared squared to me. Okay, now we have area. It is pi x squared minus pi x squared squared. Yeah, that is x to the power of 4 dx. But what is upper and lower integration limit? It is 0, 0, and 1, 1. How do we obtain? We have to find the intersection, yeah? Find A and B. Take the intersection, yeah? Take the intersection, which means equate x squared equal to x. So in this case, we have x squared minus x equal to 0, and taking common x minus 1 equal to 0. This will be x equal to 0 and x equal to, you see? So in this case, this will be A and this will be B. Now our integration will be the same as integration from 0, 1 of pi x squared minus pi x to the power of 4 x. And this one is pi x cubed over 3. This one is pi x to the power of 5 over 5. And from 0 up to 1. This will be pi over 3 minus pi over 5 minus 0, 0, yeah? Which is like, if we take the common factor 15, this will be 5 pi minus 3 pi is 2 over 15 pi unit cubed. So this is the volume to me, yeah? So this is how to find the volume of solid region, which is obtained by rotating a certain region along x-axis or along y-axis to me. Okay, do similar exercise by yourself, and this will be the end of application in the areas of volume. Okay, see you.